Hey everyone, welcome back. Today I want to share with you a technique that I use when I'm creating games in BASIC using the BASIC programming language, and I'm going to show you particularly how I go about setting up my variables and why I do it the way that I do. So here I'm using the Aquarius Plus emulator, and if you're at all interested in programming BASIC, as I've said before, the Aquarius Plus emulator is a great place to start. It's very easy to use, very responsive. The Aquarius Plus computer is a fantastic little computer and really fun to program on. So let's go ahead and get started, and I'll show you how I set up the variables in my games. So in particular, what I want to show you is the way I use a subroutine to set up my variables, which might seem obvious to you, but I'm going to show you how I do it, and I'm going to explain to you why I use a variable initialization subroutine. So what does this look like? Well, let's say we have a program here. We're making a game, let's say, and line 10 we say go sub. Let's do it in caps. Go sub line 1000, and line 1000 will be our variable initialization subroutine. So I'll say line 1000, and now we'll set up some variables. We'll say rem variable setup. Line 1010, maybe we have a variable called SC for score equals 0. Line 1020, maybe PL for players equals 2. 1030, maybe we have a string equals hello, not hello, hello player, whatever. So we have a subroutine that we're using to set up variables. And then at the end of the subroutine, line 1998, return. Okay, so why do I have my return statement at line 1998 instead of 1999, which would make more sense? The reason is that another technique that I'll share with you is that when I'm making my basic programs, I like to have a fail-safe stop statement at the end of my subroutines. So in this case, I have a variable setup subroutine, which is at the end of my program typically. So I don't really need this stop statement since it's the end of my program anyway, but I'm going to show it to you because it applies to any subroutine that I use. So at line 1999, I'll have a stop statement like that. So this is just a fail-safe to make sure the program doesn't accidentally run past the end of a subroutine. So maybe I have another subroutine in my program. For example, maybe line 600, there's a subroutine for maybe player gets leveled up. So I'll say rem player level up. And then at line 610 or whatever, rem do stuff. So this subroutine will do stuff. And then at line 698 will return, and then at line 699 I'll have a stop statement. I'll say rem should never execute, just like that. So now I know if my program ever stops at one of these fail-safe stop statements, I know something's gone wrong because these stop statements should never execute. So I always put them at the end of my subroutines just as a fail-safe in case the program happens to try to run past the end of my subroutine for some reason. Okay, so now to get back to our topic of setting up variables, let's take a look at our listing here, what we have so far. Here is our variable setup subroutine starting at line 1000 and returning at line 1998. And I want to tell you why I do it this way, and you might like to try it this way yourself. So there are three main reasons why I like to do it this way. And one reason that I like to put the variable setup subroutine at the end of the program is for speed. So for example, in your main program loop, you might have a main program loop here at line 100, rem main game loop, line 110, rem do stuff, and then maybe line 499, go to 100 and do the loop over again. So I don't need a return statement in my main program loop because it's a loop. It just loops endlessly, it's not a subroutine. So I don't need a fail-safe stop statement in the main loop, and I just have my go to 100. So if we take a look at this listing now, we have line 10, go subs line 1000, which is a subroutine to set up all the variables. And then it comes back here to the main program loop at line 100, where it does stuff. And then at line 499, it jumps back to line 100. And then we have other subroutines in our program, such as this one, line 600, where the player levels up and it does stuff and it returns. So the main program loop runs continuously, and it calls other subroutines as they're needed. But in particular, today we want to talk about the variable setup subroutine. And why do I put it at the end? Well, as I was beginning to explain, one reason is because of speed. So in your main program loop, you want that to run as quickly as possible, particularly in BASIC, because BASIC is a slow interpreted language, and you want to get as much speed as you can out of it. So one way to do that is by putting your main program loop as close to the beginning of your program as possible. Why? Because every time your program executes a goto statement, and your main program loop might have several goto statements in it, for example, and the subroutines you call will probably have goto statements in it. Well, every time the program executes a goto statement, it starts looking for the line number that you want it to go to from the beginning of the program. So if you've got a lot of variable setup lines at the beginning of your program, and you're initializing all these variables at the beginning of your program, well, the program's going to have to look through all of those line numbers to find the one it's looking for every time it executes a goto statement. So to speed up the program, we put the variable initialization subroutine at the end, because all of those instructions only get executed once. We don't want them slowing down the rest of our program, particularly the program main loop, which we want to run as quickly as possible. So that's one reason we do that, for speed. Now, another reason we do it is for organization and readability. Of course, you could set up your variables as they're needed within the program at all different locations, but that can be very difficult to manage. So if you have them all initialized in one place, then you can easily see which variables you're using, which values they're initialized to, and it's very easy to read. So it keeps your program very well organized, and it maximizes readability. Now, the third reason we do this, initializing all the variables up front, including the variables that have a 0 starting value. So you might think, well, why do I need to initialize all the variables up front? I can just have the program set them as it's needed as the program runs. Whenever the variable is needed, it can initialize it on the fly within the program, which you can do, that's true. But one cool advantage of initializing everything first, including the ones that start out with a 0 value, is that it helps you manage the memory of your program. So if you're particularly concerned about how much memory your computer is using when you're programming your game, and you want to keep track of how much available memory you have left, then it's good to set up your variables ahead of time. So if we check the available memory in our program now, we can say, in this case, we'll say print free -1. This should tell me the amount of memory that's still available after our basic program has used up some of it. And here the result is 32805. Now, what if we run our program? Okay, and it's now executing this main program loop endlessly, so we'll just break out of it. All right, so now what if we do our print free statement again and see how much memory is available now? You can see it's lower. And why is it lower? Well, the size of the program is still the same, but the only difference between these two values is that we ran the program and assigned values to these variables. So if you don't assign values to the variables at once before the program runs, if you don't assign those values initially, then it can be hard to track how much memory you actually have available to you for programming in BASIC. You might have less memory available to you than you think you have. And this is a good technique to use to keep track of your memory availability as you're making your program. So normally what I do is I will do exactly this. So let's say I have my program in memory now, and I'm not sure how much memory I have left to add more features to my program. So I'll run my program, and now it will have finished initializing all the variables. All the variables will have some value, even if that value is 0, and even if that variable is not needed yet in the program, it has already been initialized, which means memory has been allocated for that variable. So I know that even the variables that are not being used yet have still had memory allocated for them, and they're taking up space in the computer. And now if I break out of my program after it's already done that initialization subroutine, I can do whatever command I need to do on my particular computer to check available memory. In this case, I'll use print free -1 again. And now I know that this number is the memory that's actually available for my program after the variables have been initialized, which is the third reason I like to initialize all my variables up front, just like this. And then it really helps me keep track of how much memory is available when I'm programming. And normally what I will do is set up my program in this way. So at the beginning there's a call to a variable initialization subroutine. In this case we say go sub 1000. That's where our variable initialization subroutine lives for this particular program. Our main program loop is between line 100 and line 499 here. And then here we have a subroutine at line 600 to 699. And whatever other code is going to live in my program. So what I will often do is put a little helper code in my program to help me check the memory. So in this case, you can see we have some free lines between line 699 and 1000, between line 499 and 600. I generally like to do this directly after my main program loop. So let's say at line 500, I'll say clear screen, and then 501 print free memory, and then I'll put free -1. And your computer might also have a command that allows you to check other types of memory, such as string memory, which this does as well. So I'll say 502 print string mem, and in this case I can use the command free bracket quote quote, just like that, and then 503 stop. So now if I run my program, now it's running, it's in the main program loop. I can break out of my program anytime now that all the variables have been initialized, and I can simply go to, in this case I've just entered my cheat code here at line 500, or helper code I should call it. I can say go to 500, and now it tells me how much memory I have available. Free memory is 32.7K, string memory is 1023, and now it keeps track of how much free memory I have available both for my basic program as well as for the string assignments in my program. So there we go. That is why I do a variable initialization subroutine at the end of my program. And this is just a little helper code to let me check the memory as I go along in my game development. So hopefully this has been interesting and maybe useful for you beginning basic programmers out there interested in making some programs or maybe some games. And again, if you want to check out the Aquarius Plus emulator, I'll put a link to it in the video description down below. It's very easy to use, very cool computer, and it's a lot of fun to play with. So as always, thanks for watching, and until next time, take care. Bye for now.